Welcome. You have nothing to do right now, nowhere to be, nothing to solve. Simply allow your body to settle, your breath to slow, and your eyes to gently close. Tonight, we are going to drift together through one of the most quietly beautiful journeys imaginable, the path that light takes as it moves across the universe. Let it carry you softly into rest. Sunlight takes about 8 minutes and 20 seconds to travel from the sun to Earth. Right now, the warm light touching the world outside your window began its journey across space just a little over 8 minutes ago. It crossed nearly 50 million kilometers of empty, silent space, arriving here so quietly and so steadily that we rarely pause to notice. That light has been traveling longer than most of us spend eating a meal. Visible light travels at exactly 29,792,458 meters per second in a vacuum. That number is precise and unchanging, a constant woven into the fabric of the universe itself. Nearly 300 million meters every single second, moving through the silence of space without slowing, without effort, without rest. It is one of the few truly fixed things in all of nature, a quiet anchor at the heart of everything we know. Light slows down when passing through glass, water, or any transparent medium. When a beam of sunlight enters a raindrop or passes through a pane of window glass, it gently eases its pace, bending ever so slightly as it does. The universe allows this quiet negotiation between light and matter. And when the light emerges on the other side, it returns to its full speed, as if the brief pause never happened at all. The human eye can detect light across a wavelength range of roughly 380 to 700 nanometers. Within that narrow band, a tiny sliver of the full spectrum of light that fills the universe, we find every color we have ever seen. Violet, blue, green, yellow, orange, red. All of the sunsets, all of the flowers, all of the faces we have ever loved, visible to us within that small, remarkable window. Photons are massless particles that always travel at the speed of light in a vacuum. Each tiny packet of light carries no mass at all. It is pure energy, moving through space at the universe's absolute speed limit. A photon does not age. From the moment it is created to the moment it is absorbed, it experiences no passage of time. In a sense, every photon lives its entire existence in a single, eternal instant. Sunlight that reaches Earth's surface has already been filtered by the atmosphere. Long before any ray of sunlight touches the ground, it passes through layers of air, each one quietly absorbing and scattering certain wavelengths. The harmful ultraviolet light is largely held back by the ozone layer high above. What arrives at the surface is a gentler, softer version of what left the sun, light that has been carefully tended on its way down to us. The atmosphere scatters blue light more than red, which is why the sky appears blue. Tiny molecules of air catch the shorter blue wavelengths of sunlight and send them bouncing in every direction across the sky. The result is that soft, familiar blue dome we look up at during the day. The sky is not a surface or a wall, it is simply light, scattered and scattered again, filling the air above us with a gentle, even glow. At sunrise and sunset, light travels through more atmosphere, turning the sky orange and red. When the sun is low on the horizon, its light must pass through a much thicker slice of air to reach our eyes. The blue and violet wavelengths scatter away before they arrive, and only the longer, warmer reds and oranges remain. The sky blushes quietly at the edges of the day, painting everything in the softest, most familiar colors. Rainbows form when sunlight refracts and reflects inside water droplets. Each tiny droplet suspended in the air after a rain acts as a small, perfect prism. Sunlight enters, bends, bounces off the inside surface, and bends again as it exits. And in that gentle passage, the white light separates into all of its colors. Millions of droplets together create the arc we see, each one contributing a single color from a single angle. Let yourself settle now, just a little more deeply. Feel the weight of your body resting, each breath arriving and leaving on its own. There is nothing to hold on to, nothing to figure out. Let your thoughts drift like clouds moving slowly across a quiet sky. No need to follow them, no need to stop them. Simply rest here, soft and still, carried gently forward into the night. Moonlight is simply reflected sunlight, reaching Earth about 1-3 seconds after leaving the moon. The light that falls on a quiet garden on a clear night began its journey at the sun, traveled to the moon, and then made one last gentle crossing to us. That soft silver glow on the grass, on the water, on the windowsill, it is borrowed sunlight, handed along through space with quiet grace, arriving just a little over a second after it left the lunar surface. The moon reflects only about 12% of the sunlight that hits it. The lunar surface is actually quite dark, a dusty, ancient gray that absorbs most of the light it receives. And yet that small fraction, just 1 in 8 rays returned to space, is enough to cast gentle shadows on Earth, to light a path through a forest, to illuminate the face of someone gazing upward on a still night. 12% is more than enough for wonder. Light from the International Space Station takes less than 2 milliseconds to reach the ground. When the station passes overhead, a slow, bright point of light crossing the sky, the glow you see has already made its journey almost before the thought of it forms. In less time than it takes to blink, that light has crossed hundreds of kilometers of atmosphere and arrived at your eyes. It is one of the shortest journeys in this story, and one of the most quietly astonishing. The aurora borealis is produced when solar wind particles excite atmospheric oxygen and nitrogen atoms. Streams of charged particles flow outward from the sun, and guided by Earth's magnetic field, funnel down toward the polar regions. When they collide with atoms high in the atmosphere, those atoms absorb the energy and release it again, not as heat, but as light. The sky begins to glow, quietly and slowly, as if the air itself has remembered something luminous. The green color of auroras comes from oxygen atoms at altitudes around 100 kilometers. At that particular height, oxygen atoms are struck by solar particles and emit a very specific wavelength of light, a soft, luminous green that the eye finds gentle and calming. It is one of the most precise relationships in nature. A single altitude, a single element, a single color, painted across the sky in slow, drifting waves. The green aurora is oxygen, quietly singing. Light pollution from cities can reduce the number of visible stars from thousands to just dozens. The warm orange glow of streetlights and buildings spills upward into the sky, scattering through the atmosphere and washing out the faint light of distant stars. Someone standing in a city center may see only the brightest handful of stars, while someone in a dark field far away sees the full river of the Milky Way. The stars are still there. Only the quiet has been interrupted. The naked eye can see stars as faint as magnitude 6 under perfect dark sky conditions. Magnitude 6 is the very edge of human vision, the faintest whisper of light the unaided eye can detect on the clearest, darkest nights. Under such skies, thousands of individual stars become visible, and the Milky Way stretches overhead as a soft, continuous band of light. Our eyes, simply as they are, were made for this, for standing in the dark and receiving the ancient light of the sky. Our nearest stellar neighbor, Proxima Centauri, is 4.24 light-years from Earth. It is a small, dim red dwarf star, far too faint to see with the naked eye, quietly circling its 2 brighter companions in the Alpha Centauri system. Even at the speed of light, that extraordinary, unhurried constant, it would take more than 4 years to reach it. And yet, in the vast scale of the galaxy, this is the nearest star to our Sun, a neighbor in the most cosmic sense of the word. Light from Proxima Centauri takes about 424 years to complete its journey to us. Every photon that leaves that small red star travels alone through the silent dark for more than 4 years before it reaches our solar system. It passes through emptiness, through cold, through nothing at all, until at last it arrives, perhaps touching the lens of a telescope, perhaps simply dissolving into the atmosphere unseen. 4 years of travel delivered in a quiet instant. That is the patience of light. Alpha Centauri, A and B together, form the brightest component of the nearest star system. These two stars are bound to each other in a slow, graceful orbit, circling their shared center of gravity over the course of roughly 80 years. From Earth they appear as a single point of light, warm, steady, and golden, visible in the southern sky. They are companions in the truest sense, traveling together through the dark for billions of years, never far apart. Let your body settle a little more deeply now. If there is any tension left in your shoulders, your hands, your jaw, simply let it go. There is nothing to hold on to tonight. Let your breath slow, just a little, and let your thoughts drift like light moving through open space, unhurried, directionless, at ease. You are safe, and still, and gently on your way toward sleep. The star Sirius, the brightest in the night sky, lies about 8.6 light-years away. It shines with a cool blue-white brilliance that has drawn human eyes upward for thousands of years. Ancient Egyptians watched for its rising as a sign of the flooding Nile. It is not the largest or most powerful star, but its relative closeness to us makes it blaze above all others in the winter sky. A quiet, dependable presence, arriving each year without fail. Light we see from Sirius tonight left that star during the mid-1200s. When those photons began their journey, people were going about ordinary days, working, resting, watching the sky, entirely unaware that light was departing a distant star and moving quietly toward them. It traveled for years through the cold dark between stars, arriving now, in this moment, touching your corner of the world. The light you see tonight is a soft echo of a time not so long ago. Barnard's star is only 5.196 light-years away and moves faster across the sky than any other star. It is a tiny red dwarf, dim and quiet, invisible without a telescope, and yet it drifts noticeably against the background of more distant stars over just a few decades. Astronomers have tracked its steady motion for over a century, watching it glide slowly through the sky, like a lantern carried across a dark field. Unhurried, but always moving, a gentle wanderer among the stars. The star Vega, 25 light-years away, was the North Star about 14,000 years ago. Earth's axis wobbles slowly over a cycle of roughly 26,000 years, tracing a wide circle in the sky, and so the pole star changes with the ages. Long before written language, before cities or agriculture, ancient humans would have looked north and found Vega burning brightly there, steady and bright, a beacon over a world that looked very different from our own. The sky, it turns out, is not fixed, only very, very slow. Light from Vega that arrives tonight left the star around the year 2000. Those photons began their journey at the turn of a millennium, when the world was quietly marking a new century, full of small hopes and ordinary moments. For 25 years, they traveled in silence, crossing the space between stars, until tonight they complete their journey and reach the Earth. A small, unhurried delivery from the edge of living memory, the past arriving as light. Arcturus is 37 light-years away, and its light carries information about conditions there decades ago. It is a warm, orange giant star, one of the brightest in the northern sky, glowing with the deep amber color of a star in the later stages of its life. The light arriving tonight left Arcturus in the late 1980s, carrying a faint record of its temperature, its chemistry, its steady burning from that distant time. Every star is a kind of message sent long before it arrives. The Pleiades star cluster lies about 440 light-years from Earth. This small, soft gathering of blue-white stars has been named and watched by cultures across every continent. The Seven Sisters, the Subaru, the Matariki. On a clear night, they appear as a delicate smudge of light, a faint cluster you can almost see better by looking slightly to the side. They have guided sailors, marked seasons, and filled ancient skies with meaning for as long as people have looked upward. Light now arriving from the Pleiades, left during the European Renaissance. When those photons departed, painters were mixing pigments by candlelight. Astronomers were beginning to question the shape of the cosmos, and the printing press was spreading new ideas across a world on the edge of transformation. That light has traveled uninterrupted ever since, through 4 centuries of human history, and arrives tonight, softly, as if nothing has changed. The stars do not know what passed while their light was traveling, only we do. The Orion Nebula is a stellar nursery about 1,344 light-years from Earth. It hangs in the Sword of Orion, just visible to the naked eye as a soft, hazy smudge beneath the 3 belt stars. It is not a single point of light, but a vast cloud, a region of glowing gas and dust stretching across dozens of light-years. One of the closest and most studied places in the galaxy where the universe is quietly, patiently making new suns. New stars are currently forming inside the Orion Nebula from collapsing clouds of gas and dust. Deep within those luminous folds, pockets of material are slowly drawing together under their own gravity, growing denser, warming at their cores, inching toward the moment they will ignite. It is a process that takes millions of years, unhurried and immense. Even now, as you rest, new suns are being born in that quiet cloud of light. There is nothing you need to do right now. Nowhere to be, nothing to remember, nothing to solve. Let your body grow a little heavier with each breath. Let your shoulders soften and your hands open gently. Each breath out carries a little more of the day away. You are safe and still, and the universe is vast and quiet all around you. There is only this moment, and it is asking nothing of you at all. Simply rest. The light arriving from the Orion Nebula tonight left during the early medieval period on Earth. Those photons began their journey around the 7th or 8th century, when small kingdoms were rising and falling, when monks were copying manuscripts by firelight, when most of the world lived close to the land and looked up at the same stars we see tonight. That ancient light has crossed more than 1,000 years of human time to reach your eyes this evening. Betelgeuse, a red supergiant in Orion, is roughly 700 light-years away. It marks the left shoulder of the hunter and glows with a distinctly warm, reddish hue, a color that sets it apart from the cooler blue-white stars nearby. Betelgeuse is enormous by any measure. If it sat where our Sun is, its surface would extend past the orbit of Jupiter. It is one of the largest stars visible to the naked eye, burning slowly and magnificently in the winter sky. If Betelgeuse exploded tonight, we would not see the supernova for about 700 years. The light from that explosion would begin its journey across space right now, traveling at the speed of light through the dark, and it would not arrive until the year 27200. Generations upon generations of people would live and pass before that brilliant flash reached Earth. The universe operates on timescales that dwarf all of human history, and there is something deeply peaceful in that thought. The Crab Nebula is the remnant of a supernova observed by Chinese astronomers in 1054 CE. They recorded a new star so bright it was visible in daylight for weeks, shining steadily in the sky before slowly fading. What they witnessed was the death of a massive star, a catastrophic collapse and explosion that scattered its material across space. Today, that scattered material glows as a beautiful tangled cloud of filaments and light, still slowly expanding outward. The Crab Nebula lies about 6,500 light-years from Earth. The light we see from it tonight left long before any written human history, before the pyramids, before the first cities, before language was set down in clay or stone. It has been traveling across the galaxy for 65 centuries, carrying the quiet record of a star's final moment. And now it arrives here, softly, adding its ancient glow to the night sky above you. A pulsar at the center of the Crab Nebula pulses invisible light 30 times per second. At the heart of that expanding cloud of debris, the collapsed core of the original star still spins, a dense ball of matter no larger than a city, rotating 30 times every second and sending out regular pulses of light like a cosmic lighthouse. It is one of the most precisely timed objects in the universe, steady and rhythmic in the deep quiet of space. The center of the Milky Way is approximately 26,000 light-years from Earth. That is a distance so great that light crossing it takes longer than our entire recorded human civilization, multiplied many thousands of times over. On a dark summer night, the galactic center glows as a soft, dense band of light arching across the sky. It is the heart of our own galaxy, ancient and immense, and we are among its quieter outer inhabitants, resting near the edge. Dense dust clouds between Earth and the galactic center block most visible light from that region. The space between us and the heart of the Milky Way is not empty. It is filled with vast, drifting clouds of dust and gas that absorb and scatter visible light before it can reach us. It is like trying to see through many layers of gauze, each one soft and thin on its own, but together forming an impenetrable veil. The galactic center hides quietly behind this cosmic curtain, patient and still. Infrared light can penetrate the galactic dust and reveal stars near the Milky Way's core. Unlike visible light, infrared light has longer wavelengths that slip through the dust clouds almost undisturbed, carrying information from the hidden heart of the galaxy. When astronomers turn infrared telescopes toward the galactic center, an entirely new landscape appears, dense swarms of stars glowing softly in shades of amber and gold, crowded together in a way no visible light image could ever show. It is like lifting a veil and finding a quiet, luminous world beneath. A supermassive black hole called Sagittarius sits at the center of our galaxy. At the very heart of the Milky Way, surrounded by that great swarm of ancient stars, there rests an object of extraordinary mass, a black hole containing roughly 4 million times the mass of our Sun, compressed into a region smaller than our solar system. It sits there quietly, neither violent nor restless at this moment in cosmic time, simply anchoring the galaxy around it with its immense gravity. Stars orbited in slow, graceful ellipses, like embers circling a deep and patient fire. There is nothing you need to hold on to right now. Let your thoughts drift like slow clouds across a dark sky, each one passing gently without asking anything of you. Feel the weight of your body settle a little more with each breath, your shoulders softening, your hands growing still, your breath finding its own quiet rhythm. You are safe and restful, and the night is long and peaceful. Let yourself drift a little further now, carried gently by the stillness around you. The first image of Sagittarius A was captured by the Event Horizon Telescope in 2022. Using a global network of radio telescopes working together as a single Earth-sized instrument, astronomers gathered enough light to resolve the shadow of the black hole at our galaxy's center for the very first time. The image showed a soft, glowing ring of warm orange light surrounding a dark central region, the boundary where light bends and curves before disappearing. It was a quiet, remarkable moment, humanity seeing, for the first time, the ancient heart of its own home galaxy. Light cannot escape a black hole once it crosses the event horizon. The event horizon is not a physical surface, but a boundary, the point in space beyond which the gravitational pull becomes so strong that even light, traveling at its full speed, cannot pull free. Any photon that crosses this invisible threshold simply continues inward, spiraling toward the center, never to return. It is a place of absolute stillness in a way, not violent or dramatic, but simply final, like a shore beyond which the sea becomes something else entirely. The Milky Way galaxy is about 100,000 light-years in diameter. If you could step outside the galaxy and look down upon it, you would see a broad, flat spiral of hundreds of billions of stars, glowing arms curving outward from a bright central bulge, all of it slowly rotating through space. From edge to edge, this structure spans a distance that light itself, the fastest thing in the universe, takes 100,000 years to cross. It is immense beyond easy imagining, and yet it is only one of countless galaxies in the universe. Light takes 100 million years to cross the full width of our galaxy. A single photon, born in a star on one side of the Milky Way and traveling in a straight line toward the other side, would spend 100,000 years on that journey, passing through the arms of the spiral, through regions of gas and dust and open space, long before it ever arrived. In that time, civilizations could rise and fall many thousands of times on a small planet like ours. The galaxy is not just large, it is ancient in its distances, vast in a way that invites only quiet wonder. The Milky Way's disk is relatively thin, only about 1,000 light-years thick in most places. For all its enormous width, our galaxy is surprisingly flat, like a coin compared to its diameter, or a piece of paper seen from the side. Most of the galaxy's stars, gas, and dust are gathered into this thin disk, orbiting together in a broad, slow rotation. Our own sun sits within this disk, and when we look toward the band of the Milky Way on a clear night, we are simply looking along the flat plane of our own cosmic home. Globular clusters orbit the Milky Way at distances up to 130,000 light-years. Beyond the flat disk of the galaxy, in the vast spherical halo of space surrounding it, ancient balls of stars called globular clusters move in slow, sweeping orbits. Each cluster contains hundreds of thousands of stars packed closely together, some of the oldest stars in the universe, glowing softly in pale gold and white. They drift through the halo, like quiet lanterns, far from the busy disk below, tracing enormous paths through the dark that take hundreds of millions of years to complete. The Large Magellanic Cloud is a satellite galaxy about 160,000 light-years away. Just beyond the edges of the Milky Way, like a small companion drifting alongside a larger one, the Large Magellanic Cloud floats in the southern sky. It is an irregular galaxy, smaller and less structured than our own, a soft cloud of stars and glowing nebulae. At 160,000 light-years, it is one of our nearest galactic neighbors, close enough to feel almost familiar, a gentle presence in the dark beyond our own shores. Light from the 1987 supernova in the Large Magellanic Cloud arrived at Earth in February 1987. One night in February of that year, a star in the Large Magellanic Cloud reached the end of its life in a tremendous explosion, and 160,000 years later, the light from that moment finally arrived here. Astronomers around the world turned their instruments toward the southern sky and watched. It was the brightest supernova observed from Earth in nearly 4 centuries, not a cause for alarm, but a quiet reminder that the universe is always speaking to us across unimaginable distances in its own unhurried time. The Small Magellanic Cloud lies about 200,000 light-years from the Milky Way. A little farther out than its larger companion, the Small Magellanic Cloud drifts through the southern sky as a quieter, more delicate presence. It, too, is an irregular galaxy, a loose gathering of stars and gas bound together by gravity, slowly orbiting the Milky Way. At 2,003 light-years, the light reaching us from it tonight began its journey long before our species walked the Earth, a soft, patient traveler arriving at last in our eyes. Both Magellanic Clouds are visible to the naked eye from the southern hemisphere. On a clear, dark night, far from city lights in the southern half of the world, you can look up and see them without any telescope, two soft glowing patches drifting near the constellation of the Southern Cross. They look almost like pieces of the Milky Way that have broken gently away. For centuries, sailors used them to navigate the southern seas, steady companions in the night sky, and today they remain one of the most quietly beautiful sights available to the unaided human eye. Let yourself settle a little more deeply now. There is nowhere to go, nothing to hold on to, nothing that needs your attention tonight. Let your shoulders soften. Let your hands rest open and easy. Feel the gentle weight of your body, supported and still. Your breath is slow and even, rising and falling on its own. You are here, you are safe, and the whole quiet universe is simply drifting around you. Let any remaining thoughts float away, like light traveling through the dark, unhurried, weightless, and free. The Andromeda Galaxy is the most distant object visible to the naked eye, at 253.7 million light-years. On a very dark, clear night, if you know where to look in the constellation Andromeda, you can just make out a faint, soft smudge of light, barely there, gentle as a breath on glass. That smudge is an entire galaxy of stars, more than 2.5 million light-years away. It is the farthest thing your unaided eyes will ever see, a tiny ghost of light that has crossed an almost incomprehensible distance to rest, at last, upon your gaze. Light we see from Andromeda tonight left that galaxy before Homo sapiens existed on Earth. When the photons now arriving from Andromeda first began their journey, our species had not yet come into being. The Earth existed, and life moved across it, but the long story of human beings had not yet begun. Those photons traveled through the dark for more than 2.5 million years, crossing intergalactic space in silence, and only now, tonight, do they complete their journey, arriving in the eyes of the very creatures who would one day learn to wonder about them. Andromeda contains roughly 1 trillion stars, compared to the Milky Way's estimated 300 billion. Our own galaxy is vast and filled with hundreds of billions of stars, and yet Andromeda holds perhaps 3 times as many, 1 trillion suns, each one a world of light and energy, gathered into a great spiral. If you could somehow count 1 star per second, it would take more than 30,000 years to count them all. And yet from here, the whole trillion-star system appears as nothing more than that faint, soft smudge in the night sky, humble and still. Andromeda and the Milky Way are moving toward each other and will merge in about 4 or 5 billion years. Slowly, across an almost unimaginable span of time, our galaxy and Andromeda are drawing closer. In about 4.5 billion years, the two will meet and begin a long, graceful merging. Not a violent collision, but a slow interweaving of stars and space, the two spirals gradually becoming one. Most stars will never touch. The distances between them are too vast. It will simply be a quiet, cosmic dance. Two great systems, finding a new shape together over billions of years. The Triangulum Galaxy, the third largest in the local group, lies about 273 million light-years away. A little farther out than Andromeda, the Triangulum Galaxy drifts quietly in the constellation of the same name. It is smaller than both the Milky Way and Andromeda, a loose, open spiral with fewer stars and a gentler structure, almost transparent at its edges. Together, these 3 galaxies and their smaller companions form the local group, our own small neighborhood in the vast web of the universe, a handful of lights gathered close in the immeasurable dark. The local group of galaxies spans roughly 10 million light-years in total diameter, our small neighborhood in the universe. The Milky Way, Andromeda, Triangulum, and dozens of smaller companions stretches across a space 10 million light-years wide. That is a distance so large it becomes almost restful to contemplate, a vastness that asks nothing of us but quiet wonder. All of these galaxies drift together through space, loosely bound by gravity, a gentle family of lights scattered across the dark. Light from the farthest local group galaxies takes tens of millions of years to reach us. Even within our own galactic neighborhood, light must travel for tens of millions of years just to cross from one side to the other. The photons arriving from the most distant members of the local group began their journey long before the first humans, long before the first mammals, long before many of the creatures we know today had yet appeared. And still, they travel quietly, faithfully, crossing the dark until they arrive. The Virgo cluster, the nearest large galaxy cluster, is about 53 million light-years away. Beyond the local group, space opens into something much grander. The Virgo cluster is the nearest great gathering of galaxies, a rich, sprawling collection sitting some 53 million light-years from where we rest tonight. At that distance, the light now reaching us has been traveling since long before any human memory, carrying its quiet message across a gulf of space and time that the mind can only gently hold, like water in an open hand. Light from the Virgo cluster left when early whales were first evolving on Earth, 53 million years ago. When the photons now arriving from the Virgo cluster first set out, the ancestors of whales were still small, four-legged creatures beginning their slow return to the sea. The continents looked different. The oceans were warmer. Life on Earth was quietly reshaping itself into forms we would one day recognize. And all that time, across all those millions of years, this light was simply traveling, patient, unhurried, crossing the dark toward tonight. The Virgo cluster contains more than 1,300 galaxies bound together by gravity. More than 1,300 galaxies share the Virgo cluster, each one a vast system of billions of stars, all held together in a slow gravitational embrace. Spiral galaxies, elliptical galaxies, small irregular ones, all gathered into one enormous community. The combined gravity of all that matter binds them gently across millions of light-years, a quiet congregation of light that has been drifting together through space for billions of years. Let your body settle a little more deeply now. Feel the weight of your limbs, the softness of wherever you are resting, and allow yourself to simply be still. There is nothing to hold on to tonight, no thought that needs finishing, no task that cannot wait until morning. Let your breath come slowly, and with each slow exhale, feel the day releasing its hold on you. You are safe, and you are still, and there is nothing required of you now but to drift gently toward sleep. Metis 7, a giant elliptical galaxy in the Virgo cluster, hosts a black hole of 6.5 billion solar masses. Among all the galaxies in the Virgo cluster, Metis 7 stands out for its extraordinary heart. At its center sits a black hole with a mass of 6.5 billion suns, a gravitational presence so immense it is almost impossible to hold in the mind. And yet it rests there quietly, at the center of an enormous elliptical galaxy, surrounded by trillions of stars, a deep and ancient stillness at the heart of all that light. The first ever image of a black hole's shadow was captured from Metis 7 in 2019. In 2019, a global network of radio telescopes worked together as one enormous instrument and produced something humanity had never seen before, a real image of a black hole's shadow. It appeared as a soft, glowing ring of orange light surrounding a region of deep darkness, the shadow cast by Metis 7's immense black hole. It was a quiet, humble-looking image, and yet it carried within it one of the most profound things our species has ever witnessed. Jets of plasma from Metis 7's black hole shoot out at nearly the speed of light. From the region just outside Metis 7's black hole, two enormous jets of plasma extend outward into space, moving at nearly the speed of light. They stretch for thousands of light-years, long, bright streams of energy flowing away from the center in opposite directions. And yet from our distance of 53 million light-years, they appear as nothing more than a faint, soft streak of light, all that energy rendered into quiet stillness by the vastness between us. The Coma cluster of galaxies lies about 3,201 million light-years from Earth. Farther still, Well beyond the Virgo cluster, the Coma cluster drifts in the darkness, a rich, dense gathering of galaxies, sitting some 321 million light-years away. Light now arriving from the Coma cluster began its journey long before the first dinosaurs walked the Earth, when the planet was home to creatures we would barely recognize. That light has been crossing the universe quietly ever since, and tonight it completes its long, unhurried passage to us. Fritz Zwicky studied the Coma cluster in 1933 and first proposed the existence of dark matter. When the Swiss astronomer Fritz Zwicky turned his attention to the Coma cluster in 1933, he noticed something quietly puzzling. The galaxies within the cluster were moving far too fast to be held together by the visible matter alone. Something invisible, something vast and undetected, had to be providing the gravitational glue. He called it dark matter, a gentle, almost poetic name for something we still cannot see, only feel through its quiet, steady pull on everything around it. The Perseus cluster emits X-ray light and contains a sound wave propagating through hot gas. The Perseus cluster glows not in visible light, but in the deep invisible frequencies of X-rays, its hot gas radiating with quiet intensity across hundreds of thousands of light-years. Astronomers studying that gas discovered something remarkable, a sound wave moving through it, a slow, vast ripple spreading outward like a whisper through still water. It is the lowest note ever detected in the universe, far too deep for any human ear, a long and patient vibration traveling through the fabric of the cosmos. The Virgo supercluster, also called Laniakea, spans about 520 million light-years. Our Milky Way does not drift alone in the universe. It belongs to a vast flowing structure called the Laniakea supercluster, a word drawn from the Hawaiian for immeasurable heaven. Laniakea stretches across some 520 million light-years, a great river of galaxies slowly curving toward a gravitational center called the Great Attractor. It contains the mass of 100 million billion suns, and within all of that, quietly, our small galaxy rests like a single grain of sand on a very long shore. Our Milky Way sits near the outer edge of the Laniakea supercluster. Within the great sweep of Laniakea, our galaxy occupies a quiet, peripheral place, not at the center, not at the heart of things, but near the outer edge in a relatively calm and uncrowded region. There is something gently comforting in that. We are not in the midst of the busiest, most crowded part of the structure. We rest at its margins in a softer, quieter neighborhood, far from the densest gatherings of galaxies, with open space stretching away in all directions around us. The Shapley supercluster, one of the most massive concentrations of galaxies, lies about 650 million light-years away. Even farther along our outward journey, some 650 million light-years from Earth, lies the Shapley supercluster, one of the most massive concentrations of galaxies in the observable universe. It contains dozens of galaxy clusters and thousands of individual galaxies, all bound together in a gravitational embrace that stretches across hundreds of millions of light-years. Light now arriving from the Shapley supercluster began its journey, when the first complex animals were only just beginning to appear in Earth's ancient seas. The Sloan Great Wall is a vast filament of galaxies, stretching about 137 billion light-years. At a distance of roughly 1 billion light-years, astronomers mapping the large-scale structure of the universe discovered an enormous wall of galaxies, the Sloan Great Wall. It stretches across roughly 137 billion light-years, one of the longest single structures ever mapped at the time of its discovery. It is not a solid wall, but a long, gossamer filament, a thread of galaxies woven together by gravity across distances. The mind can only soften into quiet wonder, too vast to fully grasp, and beautiful for exactly that reason. There is nothing you need to do right now, nowhere you need to be. Let your body grow heavier with each slow breath, sinking gently into the warmth beneath you. Let your thoughts loosen their hold, drifting apart like wisps of cloud dissolving into a wide, quiet sky. You have traveled far tonight, across millions and billions of light years, and now it is time to simply rest. Let the vastness of it all hold you softly. You are small and safe, and cradled in something immeasurably large. Breathe slowly, let go, drift. Cosmic filaments are the largest known structures in the universe, connecting galaxy clusters. When astronomers mapped the universe at the very largest scales, they found it was not scattered randomly, but woven into a great cosmic web. Long filaments of gas, dark matter, and galaxies stretch between the densest clusters, connecting them like threads in an enormous three-dimensional tapestry. These filaments are the largest structures in the known universe, spanning hundreds of millions of light years. And yet they are also among the most delicate, thin, luminous threads crossing the darkness, holding the universe's largest gathering places in a quiet, patient embrace. Voids between cosmic filaments can be hundreds of millions of light-years across and nearly empty. Between the great filaments of the cosmic web lie the voids, immense quiet regions of space that are nearly empty of galaxies. Some of these voids stretch for hundreds of millions of light-years in every direction. Vast open expanses where only the faintest wisps of matter drift in near total solitude. They are not nothing, they are filled with dark matter and a handful of wandering galaxies, but they are as close to true emptiness as the universe offers. Enormous, still, and profoundly peaceful. The Hercules, Corona Borealis Great Wall, spans roughly 10 billion light-years, the largest known structure. At the very edge of what we can observe, astronomers have traced the outline of something almost incomprehensibly large, the Hercules Corona Borealis Great Wall, spanning roughly 10 billion light-years. It is the largest known structure in the observable universe. A vast concentration of gamma ray bursts hinting at an enormous underlying gathering of matter. It stretches across more than a tenth of the entire observable universe, and it rests there quietly, at the far horizon of everything we can see, immense and unhurried, a soft boundary at the edge of the known world. Quasars are among the brightest objects in the universe, powered by actively feeding black holes. Deep in the hearts of distant galaxies, supermassive black holes are slowly drawing in vast amounts of surrounding gas and dust. As that material spirals inward, it heats to extraordinary temperatures and blazes with an almost unimaginable brightness. These blazing cores are called quasars, and they outshine everything around them with a steady, radiant glow. They burn quietly across the cosmic distance, ancient beacons shining from the far reaches of space and time. The quasar 3C 2033 is about 2.4 billion light-years away and was the first quasar identified. In 1963, astronomer Martin Schmidt studied a peculiar star-like object and realized its light had been stretched enormously by the expansion of the universe, placing it at a staggering distance. That object, known as 3C 2023, became the first confirmed quasar. Its light has been traveling toward us for 204 billion years, crossing an almost incomprehensible expanse of space, and yet it arrives here gently, a quiet point of ancient brilliance in our night sky. Some quasars outshine their entire host galaxies by factors of thousands. A galaxy may contain hundreds of billions of stars, each one burning with its own steady light. And yet a single quasar at its center can pour out thousands of times more energy than all of those stars combined. The galaxy itself becomes almost invisible beside it, a faint, soft halo surrounding one blazing core. It is a quiet reminder of just how much energy the universe can concentrate into a single, small, radiant point, burning steadily across the ages. Light from distant quasars is stretched to longer wavelengths as the universe expands. When light leaves a quasar billions of light years away, it begins its long journey through expanding space. As the universe stretches, the very fabric of space between us and the quasar grows wider, and the light waves riding through it are gently pulled longer. What began as high-energy ultraviolet light slowly shifts toward the red end of the spectrum over billions of years of travel. It is a gentle, patient transformation, the universe quietly reshaping light as it carries it home. This stretching of light is called redshift and reveals how fast galaxies are receding from us. When astronomers measure the spectrum of a distant galaxy and find its light shifted toward the red, they can calculate precisely how fast that galaxy is moving away. The greater the redshift, the faster the recession, and the farther the source. Redshift is one of the most powerful tools astronomers have, a quiet signature written into the light itself, carrying the story of cosmic expansion across billions of years and billions of light-years of empty, silent space. Edwin Hubble discovered in 1929 that galaxies are moving away and the universe is expanding. Working at the Mount Wilson Observatory in the quiet mountains above Los Angeles, Edwin Hubble carefully measured the distances and velocities of nearby galaxies. He found something extraordinary. Almost every galaxy was moving away from us, and the farther it was, the faster it receded. This single, patient observation reshaped our understanding of the cosmos entirely. The universe was not static and eternal. It was growing gently and continuously, in all directions at once, like a slow, silent breath. The Hubble constant describes the rate at which the universe is expanding per unit distance. Astronomers express the pace of cosmic expansion as a single number, the Hubble constant, which tells us how quickly space is stretching for every unit of distance between galaxies. Current measurements place it at roughly 67 to 73 kilometers per second per megaparsec, though scientists are still gently working to reconcile slightly different values from different methods. It is a quiet, steady number at the heart of cosmology, a soft pulse describing the universe's slow, continuous, unhurried growth outward in all directions. There is nothing more you need to hold on to right now. Let your thoughts grow quiet and still, like the surface of a deep lake settling after a long, gentle day. Feel the weight of your body, heavy and at ease, resting completely. Each breath in is slow and soft. Each breath out releases a little more. You have traveled so far tonight, through galaxies and quasars and the slow stretching of ancient light. Now simply let it all go. Let the darkness be soft and kind. Let sleep come as gently as light drifting across the universe. As light travels across billions of light years, its wavelength stretches from ultraviolet toward infrared. A photon born in the heart of an early galaxy may have begun its life as energetic ultraviolet radiation, blazing with intensity. But as it crosses billions of light years of expanding space, each passing eon gently stretches it a little further. By the time it arrives at our telescopes, it has been transformed into infrared light, warm, long, invisible to the human eye, but detectable by our most sensitive instruments. It is the universe's own quiet alchemy, turning the energetic into the gentle over immeasurable time. The most distant galaxy observed so far, Jade's Z14 Shuvertine, existed about 2,000 million years after the Big Bang. With the James Webb Space Telescope, astronomers have glimpsed a galaxy that formed when the universe was barely an infant, only 2,000 million years old, a tiny fraction of its current age. This galaxy, known as Jade's GS14-0, is a faint, ancient smudge of starlight from a time when the cosmos was still finding its earliest shapes. Its light has traveled more than 13 billion years to reach us, a whisper from the very edge of the beginning, arriving softly and quietly into our waiting instruments. Light from that galaxy has traveled for more than 13.4 billion years to reach our telescopes. Consider that for a quiet moment. Every photon we have gathered from Jade's GS14-0 has been journeying through expanding space since long before our Sun, our Earth, or any living thing existed. It crossed distances that have no comfortable human scale, passing silently through the dark between galaxies, never pausing, never resting, until it finally settled into our instruments, like a letter arriving from the very beginning of time. The James Webb Space Telescope detects infrared light from the universe's earliest galaxies. Orbiting nearly 1.5 million kilometers from Earth, Webb was built specifically to listen for the ancient stretched light of the cosmos's first structures. Its instruments are cooled to temperatures near absolute zero, making them exquisitely sensitive to the faintest infrared whispers. With each observation, it reaches further back in time than any telescope before it, quietly gathering light that has wandered the universe for longer than our planet has existed. Webb's mirror spans 65 meters, giving it unprecedented sensitivity to ancient, red-shifted light. That primary mirror, composed of 18 interlocking hexagonal segments, each coated in a whisper-thin layer of gold, was assembled with extraordinary care. Gold reflects infrared light with exceptional efficiency, making it the perfect material for catching the oldest, most stretched photons in the universe. When all 18 segments work together as one, they form a single eye nearly 7 meters wide, opening gently toward the farthest reaches of time. Gravitational lensing bends light around massive galaxy clusters, magnifying objects behind them. When light from a very distant galaxy passes near an enormous concentration of mass, a whole cluster of galaxies, the fabric of space, curves around it, and the light curves with it. Like a lens made of gravity itself, the cluster bends and focuses that ancient light, redirecting it toward our telescopes. Objects that would otherwise be far too faint to detect are gently brought into view, their light gathered and amplified by the patient architecture of space. Einstein predicted gravitational lensing in his general theory of relativity in 1915. More than a century ago, Albert Einstein sat with his equations and realized that mass does not merely attract other mass, it bends the very space through which light travels. His general theory of relativity described gravity not as a force, but as a curvature, a gentle warping of space-time around anything with mass. He predicted, quietly and mathematically, that a massive enough object would deflect passing light, bending its path the way a glass lens bends a beam of sunlight. The first confirmed gravitational lens was observed in 1979 as a double image of a quasar. Decades after Einstein's prediction, astronomers studying a distant quasar noticed something unexpected and quietly remarkable: two images of the same object sitting side by side in the sky. A galaxy lying between Earth and the quasar was bending the quasar's light along two separate paths, each arriving at slightly different angles to produce a twin. It was the universe gently confirming what the equations had long suggested, a soft echo of a century-old idea finally made visible. Einstein rings form when a background source, lens, and observer align perfectly. When a distant galaxy, a massive lensing object, and our telescope fall into exact alignment, something beautiful emerges. Background galaxy's light is bent equally in every direction around the lens, spreading into a complete, luminous circle, a ring of light surrounding the lensing mass. Astronomers call these Einstein rings, and they are among the most serene and geometrically perfect structures the universe produces, a quiet reminder that the laws of physics can arrange themselves into something very nearly like beauty. Gravitational lensing can multiply the apparent brightness of a distant galaxy by factors of tens. A galaxy so faint it would be entirely invisible to even our most powerful instruments can, when lensed by a foreground cluster, appear tens of times brighter than it truly is. The mass of the cluster acts as a natural cosmic magnifier, gathering and focusing light that would otherwise have dispersed into the dark. In this way, the universe itself helps us see further and deeper, quietly offering ancient light that would otherwise remain forever hidden beyond the reach of our instruments. There is no need to hold any of this in your mind right now. Let the galaxies and lenses and rings of light simply drift past, like slow clouds crossing a dark sky. Feel your breath moving softly, in and out. Each exhale a little longer, a little quieter. Let your shoulders settle. Let your hands rest. The universe will continue its patient work while you sleep. All that ancient light will keep traveling. You have nothing to do now but let go and allow the gentle dark to carry you, slowly, softly, toward rest. Cosmic microwave background radiation is the oldest light in the universe. Long before any star ignited, long before any galaxy assembled itself from drifting gas, the universe was filled with a glowing, opaque warmth. As it expanded and cooled, that primordial light was finally released, free to travel, free to cross the cosmos. We call it the cosmic microwave background, and it reaches us today from every direction at once, a soft, ancient glow that has been traveling since the universe was only 300,000 years old, the quietest and most ancient light there is. The CM was released about 380 years after the Big Bang, when the universe cooled enough for atoms to form. In those earliest stages, the universe was unimaginably hot and dense, a place where electrons and protons could not yet hold together. But as it expanded and cooled, something quietly shifted. Electrons settled into orbit around protons, forming the first hydrogen atoms, and in that moment of calm, light was finally free to travel. That release, gentle, gradual, inevitable, marked the universe's first great opening. Before the CM was released, the universe was opaque, and no light could travel freely. Imagine a world of pure, warm fog, light-born and immediately absorbed, scattered, unable to find its way. Every photon that tried to move was caught almost at once, the universe too dense and too hot to allow passage. There was no darkness, but there was no clarity either, only a glowing, impenetrable warmth filling everything, a kind of cosmic stillness before the first true light was allowed to travel. The CME has a nearly perfect blackbody spectrum with a temperature of 2725 Kelvin. Just barely above absolute zero, this ancient light carries a temperature so close to nothing that it hums quietly at the very edge of cold. A blackbody spectrum is the purest kind of thermal glow, smooth, even mathematically precise. The CE matches this ideal almost perfectly, a fact that still quietly astonishes scientists. It is as though the early universe left behind a perfectly tuned note, still softly sounding across all of space. Tiny temperature fluctuations in the CM reveal the seeds of all future galaxies and clusters. When astronomers map the CM in fine detail, they find it is not perfectly uniform. Across its vast expanse are the faintest of ripples, temperature differences of only 100,000th of a degree. Yet these whisper-thin variations were enough. Over billions of years, gravity gathered matter around those slight overdensities, slowly building every galaxy, every cluster, every filament we know. All the structure of the universe grew from these quietest of beginnings. The CM was accidentally discovered by Penzias and Wilson in 1965 using a radio antenna. Two radio astronomers in New Jersey were troubled by a persistent, unexplained hiss in their antenna, a soft, even noise that came equally from every direction and would not go away. They checked for every possible cause, even clearing pigeons from the dish. What they had found, without searching for it, was the oldest light in the universe, a quiet, accidental discovery that would reshape our understanding of where everything began. The Planck satellite mapped the CM with extraordinary precision between 2009 and 2013. Launched into the quiet cold of space, the Planck satellite spent years listening, turning slowly, scanning the whole sky, recording the faintest temperature variations in the ancient light. Its instruments were cooled to nearly absolute zero, so they could hear this whisper without distortion. The maps it returned were the most detailed portraits ever made of the early universe, a patient, careful record of light that had been traveling for nearly 14 billion years. Team photons have been traveling for about 13.8 billion years since they were released. Each one of those ancient photons has been moving, uninterrupted, since the universe was young and formless. They have passed through the darkness before the first stars, through the formation of galaxies, through billions of years of cosmic change. And now, tonight, some of them are ending their journey here, arriving at Earth, at our instruments, at the space above the quiet place where you are resting. An unimaginably long journey, arriving gently. The surface of last scattering, where seen photons originated, is about 46 billion light-years away today. The place where that ancient light was first released has not stayed still. The universe's expansion has carried it far beyond where the light itself has traveled. Scientists call this the surface of last scattering, a spherical shell surrounding us in every direction. It marks the farthest edge of everything we can see with light. Beyond it, in every direction, lies the opaque early universe, a soft, glowing boundary at the very edge of the visible cosmos. Although SEAM photons traveled 13.8 billion years, the universe's expansion places their origin farther away. This is one of the quieter wonders of cosmology. Photons themselves traveled for 13.8 billion years, but the space they traveled through has been stretching all along. The place they came from has been carried outward by that expansion, so that today it sits roughly 46 billion light-years away. Distance and time do not simply add up in an expanding universe. They stretch and deepen, like a story whose beginning keeps receding as you read it. Let your body settle a little more deeply now. There is nothing to hold, nothing to carry. Let your thoughts grow quiet, like ripples on water slowly stilling. Feel the weight of your limbs, heavy and warm. Let each breath come and go without effort, in softly and out slowly. The universe is vast and patient, and it asks nothing of you tonight. You are held, gently, in this moment. Let the ancient light keep traveling on its own, and let yourself drift, softly and without effort, toward sleep. The observable universe has a radius of about 46.5 billion light-years due to cosmic expansion. It is a sphere of everything light has had time to reach us from, a vast, luminous bubble of knowable space, centered quietly on wherever you happen to be. Every galaxy, every star, every ancient photon we have ever detected lives within this gentle boundary. And yet, this immensity is not the whole of existence. It is simply the portion the universe has allowed us to see, for now. Beyond the observable universe, space continues, but its light has not yet had time to reach us. There is more, far more, lying quietly beyond the edge of what we can see. Space does not end at our horizon. It simply continues, unhurried and immense, filled with galaxies and stars we will never observe. Their light is traveling toward us, perhaps, but the universe is too vast and too young for it to have arrived. There is comfort in that, in knowing the cosmos is larger than any eye can hold. Dark energy is causing the universe's expansion to accelerate, a discovery made in 1998 through careful observations of distant supernovae. Scientists studying the brightness of these ancient stellar explosions found that the universe was not merely expanding, it was expanding faster and faster over time. Something unseen, which we call dark energy, is woven into the fabric of space itself, gently pressing outward. We do not yet fully understand what it is, but it moves through everything, quietly and without pause, like a slow tide with no shore. Distant galaxies beyond a certain distance are receding faster than light can bridge the gap, This is not a contradiction of physics. Space itself is stretching, and when enough of it lies between us and a distant galaxy, that stretching outpaces even light's steady travel. The light from those galaxies runs toward us faithfully, but the ground beneath it keeps moving away. It is a quiet, unhurried race, played out across billions of years, in the deep and patient dark between worlds. This means some regions of the universe are permanently beyond our observational horizon. No matter how long we wait, no matter how powerful our instruments become, certain parts of the cosmos will remain forever out of reach. They exist, scientists believe they do, but they are sealed from us by the mathematics of expansion. There is something deeply peaceful in accepting that. The universe holds its own quiet secrets, not to tease, but simply because it is vast beyond any single vantage point. Light from those regions will never reach Earth, no matter how long we wait. It is a thought that asks nothing of us, only a gentle acknowledgement of limits. The universe is larger than any light can cross. Some photons are journeying outward in places so remote that every second they travel, the space ahead of them grows faster than they can follow. They will move forever through the dark, never arriving anywhere we can know. And somehow, that is not a loss, only a quiet measure of how immense everything is. The photon sphere around a black hole is where light orbits in unstable circular paths. At a precise distance from a black hole's center, about 1.5 times the event horizon, gravity is strong enough to bend light into a perfect circle. Photons there do not fall in, but neither do they escape. They loop endlessly in a thin glowing ring around the darkness. It is one of the strangest and most beautiful places physics describes, a halo of trapped light, circling forever at the edge of the unknowable. Hawking radiation is a theoretical process by which black holes slowly emit thermal light over immense stretches of time. Stephen Hawking proposed in 1974 that quantum effects near the event horizon allow a black hole to radiate a faint, steady warmth not from inside, but from the boundary itself. The radiation is extraordinarily faint, far below anything we could currently detect. But the theory suggests that even the darkest objects in the universe are not entirely silent, that even they, over unimaginable time, whisper a little light back into the cosmos. If Hawking radiation exists, a stellar mass black hole would take 10 to the power of 67 years to fully evaporate. That number is so large, it dissolves into pure abstraction, a duration compared to which the current age of the universe is less than a single breath. The universe would have long since grown cold and dark. Every star would have burned out, every galaxy scattered. And still, somewhere in the quiet void, a black hole would be slowly, patiently, giving its last faint light back to the universe. Unhurried, inevitable, gentle. Photons, emitted at the Big Bang itself, were gamma rays of enormous energy. In the very first moments of existence, the universe was a blazing, unimaginably hot furnace, and the light born there was the most energetic light that has ever existed. Those primordial photons carried more energy than any light produced since. The universe was young and radiant, and its first breath was made of light, fierce, brilliant, and formless, flooding outward into a space that was only just beginning to be. Let yourself settle now, gently and completely. Feel the weight of your body resting, fully supported, with nothing asked of you. Let each breath come a little slower, a little softer. Your thoughts can drift like distant light, passing through, not staying. There is nowhere to go and nothing to hold. Just this quiet, this warmth, this ease. You are safe, you are still. Let the darkness be gentle, and let sleep find you, slowly and naturally, in its own time. As the universe cooled and expanded, those primordial gamma-ray photons stretched into lower energy forms. What began as fierce, blazing radiation gradually softened over billions of years, wavelengths lengthening, energy gently fading, like a note held long after the instrument has gone quiet. The universe was cooling, breathing out, settling into something calmer. Those ancient photons did not disappear. They transformed, slowly and quietly, into the gentler light we still find woven through all of space today. Today, the universe is filled with roughly 11 cm photons per cubic centimeter everywhere, not just in deep space between galaxies, but here, in this room, in the air around you, passing through you even now in their countless billions. They are the quietest presence imaginable, ancient, cool, invisible, and everywhere at once. The universe does not leave any corner empty. It fills every last breath of space with this soft, ancient light, a warmth so faint it is almost nothing, and yet it is everywhere. Light carries momentum and exerts a gentle pressure, a force so delicate it is called radiation pressure. Though a single photon pushes with almost nothing, vast numbers of them together can move matter across the void. Engineers have imagined spacecraft with enormous, paper-thin sails, catching the steady breath of starlight the way an ancient ship once caught the wind. No engine, no fuel, just the patient, endless push of light itself, carrying a vessel quietly forward through the dark between the stars. The Parker Solar Probe has traveled closer to the Sun than any previous spacecraft, entering a region of intense and extraordinary light. Launched in 2018, it has skimmed within a few million kilometers of the solar surface, where light and heat and particle streams pour outward with tremendous force. Its instruments sample an environment no human-made object has ever entered before. It moves in silence through a place of radiance, a small, careful visitor in the brightest neighborhood our solar system holds. Future telescopes may one day detect light from population tree stars, the very first stars ever to have formed in the universe. These stars have never been directly observed. They existed in a universe still young and dark, before galaxies had fully taken shape. Their light has been traveling toward us for nearly the entire age of the universe, stretched and dimmed almost beyond detection. But astronomers believe that with the right instruments, we may yet receive that first, ancient greeting from the universe's earliest fires. Population tree stars are predicted to have formed within the first few 100 million years after the Big Bang. The universe then held no heavy elements, no carbon, no oxygen, no iron. These first stars were born from pure hydrogen and helium, and they burned with enormous intensity. They lived briefly and died violently, seeding space with the heavier elements that would one day form planets and people. They were the universe's first chapter, written entirely in light and gravity, before anything else existed. Their light, if detected, would be the most ancient starlight ever observed by humanity. To receive that light would be to reach back across nearly all of time, to touch the very first moment the universe chose to shine. Every photon from those first stars has been traveling since before our galaxy existed, before our sun was born, before Earth had formed. To catch even one of those photons would be a kind of miracle, the universe at last, letting us hear its very first whisper. Cosmic inflation theory suggests the universe expanded faster than light in its very first fraction of a second. In a moment almost too brief to name, space itself stretched from something unimaginably small to something vast, not light moving through space, but space itself growing. This does not break the rule that nothing travels through space faster than light. It is space that expanded. It is one of the most astonishing ideas in all of science, a universe that in its very first breath leaped outward into being. Every photon that has ever crossed the universe carries within it a record of its entire journey. Its wavelength holds the memory of how far it has traveled, how much the universe has stretched since it was born. Its direction tells of the source that sent it. Its energy speaks of the temperature and time of its origin. Each photon is, in its quiet way, a letter written by the cosmos, sealed at the moment of its creation, carried faithfully across all of space and time, and delivered at last here. The universe is not silent, but filled with an unending river of light flowing in every direction at once. In every cubic centimeter of space, photons are crossing, weaving, passing through one another without collision or interference. Light from ancient stars, from distant galaxies, from the first moments of time, all of it moves together in one vast, quiet flood. And here, in this moment, as you rest and breathe and let the day dissolve, that river is flowing through you too. You are held inside it, always. The universe has been shining since before the earth existed, and it will go on shining long after. You are part of that light, born from it, warmed by it, carried gently within it tonight. Let your body soften now. Let your thoughts grow still and slow. Somewhere, a photon born 13 billion years ago is completing its journey, and you, right here, are resting at the center of it all, small and quiet, and perfectly at home in this endless, luminous universe. Good night.